See, one of the widely seen IGP routing protocol is OSPF. Why is it so important? Why is it so popular? It is because of its simplicity, at the same time the efficiency. More efficient and very simple to configure. Easy to configure, easy to understand, and also very effective protocol. High resilience, high robust. You can see OSPF can support any size network. Any means any here. That is what I mean. Any size network. More routers you have, put them in small areas to accommodate it. You have that area hierarchical design, a backbone area, and all other areas connected to the backbone area. So this makes this protocol highly robust protocol, highly scalable protocol. Any number of routers. All that you need to do is put them in different area, put summarization, configure stub, OSPF stub, wherever is possible. That will keep the routing protocol more effective, make it more effective, keep it running more effective. So definitely this OSPF is the best protocol because of this one big reason. And any size topology it will fit, small, big, any size. One big autonomous system you can have with OSPF. See, we learned in EAGRP also there is a limit. Within an autonomous system, by default only 100 is supported. But you can tune up to 255 if you want. But by default only 100 is supported. But in OSPF you don't have such limitation. You don't have 255 limit. Theoretically it is said in an area you can have 255 networks. In an area you may have up to 255 networks. Like that you can have any number of areas. So this OSPF is definitely a protocol which is widely used. The other reason why this protocol is very popular is the link state. OSPF is a link state routing protocol. What does it mean? The other protocols, they advertise the routing table. Understand? You are going to London. You just landed in London. And you want to go to that Eiffel Tower, which is in Paris. You can go by bus actually from there. From Swiss you can go to Paris by bus. From Germany you can go by bus. From London you can go by bus. I have been to these places in bus, not in plane. What I'm saying is you landed and your friend is coming to meet you, and you are asking like what is the best way to go to Paris. Let's say he gives you a path saying go straight, take left, again go straight, and then again take left, and then go straight, fifth left, and then there's a roundabout, take a second exit, something like that. He is giving you the route information. Will this be okay? Or if your friend gives a very clear route map, very clear map of Europe, which has got all the possible routes and kilometers and so on. And he says, use this map, you find a way. See, two options, no? One is, friend is giving you the route to go this way. This is the best route I have seen. Go this way. That is one way of helping you. The other way is giving the map of Europe, and which has got very clear picture to not only to Paris, to Sweden, to Copenhagen, and many more, to Zurich. Everywhere you can go if you want, just by looking into the map. So what I'm coming to say is, if someone gives a map, that will be the best than giving their ideas. If you see EIGRP, it is giving its idea, meaning whatever is best for EIGRP will be there in the routing table. And EIGRP takes those routes that are there only in the routing table and gives to you. It is like your friend telling the route from his knowledge. Whereas OSPF advertises the link state, meaning it advertises the map that it knows. Every router says, hey, this is what I have discovered so far, this is what the map I have about this topology. Likewise, every router will keep sharing the knowledge that they have, not the best knowledge, not the knowledge of the routing table, but the knowledge of the map. I live in Zurich, these are all the routes that connects to these places. And the other guy says, I live in Paris, these are the routes that connects to Paris, Germany, London, da 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 da. So there are various routers in the autonomous system connected to various other routers and the links. Every router now starts advertising to whom they are connected, what is the link status, how much is the bandwidth, what will be the cost on that link, what is the subnet on that link, what area that belongs. All these things are advertised. That helps the other router to form a map by themselves. Here no router is advertising the best routes from the routing table. They advertise all routes. So it helps to create a map. Every router can create their own map by collecting these advertisements. Link state advertisements. With that map, everyone will now position themselves in their local and try to find the best path to different destination. See, you landed in my airport. They gave you a map free of cost. To you they gave, to me they gave, to all of us they gave one map. And now we all went to different part of that city and we are taking a hotel. I'm in the east corner of that city in a hotel. One of you are in west, another one is in south, another one is in north. We are all in the same city, landed in same airport, but we are located in different corners of the city. Now we want to go to a mall. We want to go to Burj Khalifa. The mall name is Burj Khalifa. Burjman, Burj Khalifa, Carrefour. These are all in Dubai, you can see. Let's say Carrefour. Carrefour is in Burjman. So we want to go to a mall called Carrefour. Now we all will pick the map, no? We all are given with the map. We pick the map. First thing what you will do in the map, you will see where we are in the map. I position myself in the east corner. One of you will position in the west, the other one will position in the north, the other one will position in the south. Okay, I am in the south, I am staying in this Holiday Inn Express. I am in the east, I will position myself in Premier Inn, something like that. Everyone position ourselves in different hotel, in different part of the city. Same map we are all using, but we position ourselves in different corner of the map. And now we will see. If I'm in east, I position myself in the east of the map. Okay, I'm in this hotel, Premium Inn. Now to go to the Carrefour, what is the best way for me? I'll see that. That will not be the best route for you, because you are in another corner. So we all use that common map and find what is best for us to reach that destination, Carrefour. At last we all reach Carrefour. This is the best one. Instead of you calling me asking, sir, how can I come to Carrefour? If you ask me what, I will say, I'm in the east, but you are in the total opposite, west. My best route will not be your best route. I don't know much about coming from west to Carrefour. So with the knowledge that I have, I may give you a route which will be bringing you to Carrefour, but in a long route, far route, long distance route. Do you want that to happen? No. That is why we don't like EIGRP. EIGRP advertises the best route only. That may not be best for us. OSPF advertises the link states using which we all have a common map now. Every router have got a common map in which they position themselves and find their own path, the best low-cost path. Cost is the metric in OSPF, the best low-cost path to reach different destinations. This is why OSPF is called as link state routing protocol. Very popular. Ask me a question, please. The complete database in every router helps OSPF to take accurate path selection. Very sharp, best path. Here not learning by rumor, not learning from the neighbor. Routes are not learned from the neighbor. Only LSAs are collected. Link state advertisements are collected from neighbor. Routes are determined by themselves. So they got the complete map, not a partial topology like EIGRP has got only partial topology. OSPF will have identical database within the area. Note down the point. Within an area, every router will have identical database. You can also say in a negative way, which is not really negative, but people will say something, only within the area OSPF will have identical database. Same statement they will say like this. But how you should see is, within a database, within the area, every router will have an identical map. Within an area, it is said you can have up to 255 networks. You have 255 networks, reachability, the database, the map, very identical. Between the areas, we do summarization. As a result, you cannot always have identical database between areas, but within an area, every area will have identical database. So if a route goes down, immediately it will look into the database and pick the second best path, the next path as the best path. If there is no path in the database, if there is no alternate path in the database, will OSPF query? No. There is no stuck in active problem here. If there is no alternate path, what does it mean? It means there is no path available. There is no point of querying anyone. So definitely OSPF is the best protocol among all other routing protocols. OSPF is like a queen of routing protocol. ISIS is the king of IGP routing protocol. ISIS is also linked state routing protocol. OSPF is also linked state routing protocol. OSPF is the queen of routing IGP protocol. ISIS is the king of IGP protocol. Why I put ISIS as a king? Because it's little difficult for you to handle this ISIS if you are a beginner. You need to be a very well versed, very clever minister in the king's palace to understand the king. ISIS is like that. The beginner engineers don't know ISIS. But that is also basically a linked state routing protocol, uses the same algorithm what OSPF uses. But everyone likes OSPF because of the simplicity. ISIS is not that simple, but it's more good than OSPF. But not much popular because of that toughness. We'll speak about ISIS after we finish OSPF. You see, what you see here is every router they start sending LSAs, linked state advertisements. That linked state advertisement helps OSPF to build an identical map. This map will be identical within the area. An identical map, linked state database. And now on this identical map, the shortest path first algorithm, Dijkstra's algorithm, will run and find the best path, low cost path for every destination, low cost path. And only the low cost path will be put into the routing table. This is how OSPF learns route. They don't learn from neighbor's routing table. They learn from within. They learn by using their own database, local database. OSPF also has got three tables: neighbor table, topology table, routing table. Neighbor table is to maintain the OSPF neighbors. Neighbor table will have the list of neighbors which matches parameters like same area, same subnet, same timer, and so on. We'll talk about that in detail later. So what I'm saying is OSPF neighbor table will have list of neighbor, which list of established neighbor. Neighbor may be via physical interface, may be via a tunnel interface, that doesn't matter. Somehow it is directly connected, either logically connected directly logically, or directly physically. Directly virtually, directly physically, that doesn't matter. Topology table, as we saw just now, it will have collection of LSAs. All LSAs from various neighbors are collected and built a common map called link state database. Contains all routers that are routers and their attached links in the area. Look at this, the third point in the topology table. Identical LSDB for all routers within an autonomous system. Is it true? Someone correct me what I said. Identical link state database for all routers within an autonomous system. Correct or not?
So within an area.
Within an area. In an autonomous system, we will have many areas. Within an area, you will have identical database. If you don't do summarization, then also the database will not be identical. Even if you don't do summarization, the link state database throughout the autonomous system, it won't be identical. We'll talk about that later. But I want to just tell why, because of the different LSA types. Now, next is the routing table. As we know, the routing table will always have the best path, best route to the destinations, best path to the destinations, using which the packets will be forwarded. You see, this explains why link state routing protocol is so important. Link state routing protocol's router recognizes more information about the network than the distance vector. Each router has got full picture of the topology if it is link state. As a result, link state routers will make more accurate decisions, path selections. Any question so far? No. Okay. OSPF follows this hierarchy. Link state routing requires a hierarchical network structure that is enforced by OSPF. So this link state routing, or ISIS is also link state routing. There also we have not exactly same but almost same hierarchy structure. Multiple areas. In ISIS also we have 2 levels of hierarchy. In here also we have 2 levels of hierarchy. In OSPF, transit area or backbone area or area 0 all are same. This is one level to which regular areas are connected. This is down level, non-backbone areas, like this. Why do we need this hierarchy design? What is the advantage of this hierarchy design? See, because you got hierarchy design, you got multiple areas. When you have multiple areas, for all the subnets of area 1, I can do summarization and send only the summary route. For every area, I can do a summary on the border router. So this router C, D and E are called as ABR routers, area border router. This is the best summarization point. See, in EAGRP, wherever you want you can do summarization. Every router will do auto summarization. That is like, indisciplined approach. This is very disciplined one. Summarization is done only on the border routers, not everywhere that we like. Very neat. So how you got the border? Because you got multiple areas. You see? Why do we need area? So that we can do summarization for this area networks here. As a result, the other area routers will not need to maintain too big routing table. Not only that, not only the routing entries are minimized, even if there is any change in the topology, it will only locally affect, it won't impact everyone, because the detailed LSAs are not flooded throughout the autonomous system, it is flooded only within an area. So we understand here why we need multiple areas. As I said here, C, D and E are area border routers. A and B are internal backbone router. And then F, G, H are internal to non-backbone areas. F is area 1 internal router, G is area 2 internal router, H is area 3 internal router. You know, every protocol has got some way to discover the neighbor. What is the way in which RIP forms neighbor? Can someone say? How RIP forms neighbor?
It sends periodic updates every 30.
Okay. You should not say that as an answer. RIP never forms neighbor. RIP never forms neighbor. That should be your answer. That should be your answer. RIP never forms neighbor. Okay, except RIP, all other protocol forms neighbor. Just to test, confuse, I use the word every protocol has got some way to form neighbor. Then I asked immediately RIP to check whether you know it. RIP never forms neighbor. EAGRP forms neighbor by sending hello. OSPF forms neighbor by sending hello. ISIS forms neighbor by sending hello. But BGP will not send hello. BGP will send three-way handshake. We'll talk about that when we go there. Now, OSPF sends hello packet to discover neighbor. Inside the hello packets, lot of things are shared in which the area ID, the timer, the subnet must match in order to accept the other guy as a neighbor. If you are sending a hello packet, I'll check these parameters. Is he coming from same area? Is the hello coming from same subnet? Do we have the same hello timers? And then only if all these three is yes, then I will accept you as a neighbor. Likewise, you accept me as a neighbor. That is what here it is said. Routers declare neighbor to be up after checking certain parameters and options in the hello packet. Alright, so we'll stop here today.